Hello. Thank you for coming to at least the first lesson of the engineering course for Virtual Makerspace. And I think most of you guys already know from our other videos that they focus more about programming. But I think why I really like this specific programming class or engineering class is that it's, I think, a little bit more hands-on compared to other programming classes, even though, we're talking through a screen and we're across, I don't know where you guys are, but we're able to connect and create and have activities to do that are physical rather than virtual. And I think that also brings new enrichment capabilities to both students to like learn and interact with, what they're going to be doing in the future. So, yeah. And before we start, I want to say that our first lesson will be covering the Leaning Tower of Pasta, and I bet you most of you guys have covered this in, not covered, but done something similar or heard of it. And in this first part of the video, we'll be specifically covering the structural integrity. So, to begin with, whenever you're looking at the structural integrity, there are some concepts that I want to discuss in this video before we go to creating, and then the last video, which will be discussing, the overall picture and what creative outlets you guys can do. So, um, the first thing I want to talk about is what you guys think the most reinforced shape is. And I mean, you could do a quick Google search or whatever, but I think there's one at least, which would be the triangle. And you could put your fingers together like this and see that there are 3 points where it connects. So there's this point, and the one on the left, as you can see. I mean, it's not good with my fingers, but those 3 points, let's say you put pressure on one of those directions, they'll be evenly distributed to the two corners of the triangle. That's why it's more reinforced. Think of if you use like a square like this, if you put pressure on one of the points, that point is able to go inwards like this. But with a triangle, you're not able to do the same downward force because then it has to go completely inverted rather than with like a square, you could just push it inwards. So that's the triangle. And talking about the square is also a good tool because, well, what's a square made out of? I mean, you tell me, whenever you put your fingers together, what can a square be made into? And let's say, I mean, if you haven't caught along, if you see that there are two sections in between the square where you can draw a line, and guess what? Now it would be two triangles instead of just one square. So adding that reinforcement between the two can make a triangle. And I bet you if you do the same thing on the other side of the square, like that way, you could have four triangles, meaning that it's going to be more structurally sound. And I think those are the two concepts. And that would just be for the base. And you could also utilize it for the sides of the spaghetti structure. But, you have to think, whenever I'm building vertically upwards, what would be the best shape to build? Because let's say you could do a triangle, you could do a square. And I mean, whenever you reference buildings outside, because I mean, where else do you learn about structural integrity besides buildings? They're usually squares. And being able to, let's say the goal of the pasta is to build it to the highest height, and by being able to understand that and being able to understand the role that triangles play and the role that squares play, you'll be able to just make the base, and after you make that base, you'll be able to start scaling it upwards and upwards and upwards. And you know on the sides of the triangles, or on the sides of the pasta, you're supposed to try to bring it upwards, as I said before. And one thing that you can do for that is to, brainstorm different ways. So I could brainstorm along with you guys. So whenever you look at buildings, there's a couple characteristics that they have. First of all, they have a foundation on the bottom, then they have structural beams that support upwards, and then they have, um, a regular like drywall. And for our case, we don't need that drywall section, but rather we just need the foundation and the supporting beams. And I think you could just do a quick example of a preliminary experiment where you get basically just a beginning experiment. So you just get a square or a triangle, and you just build, you tape two of the pasta together to make it just go vertically up on all four sides or on both sides. And then now you have a small square. And now try to scale that upwards and upwards and see where it starts to fall, because that would be the limit of that one certain building. And then do the same thing for, let's say, a foundation that's a triangle. So you do a triangle and then you build it higher and higher and higher. And after you try those, see which one comes out better. And I would, I mean, I hopefully it also depends on the materials you use, because my spaghetti might not be the same exact brand as yours, and that might lead to the structure swaying or going to different heights because of the rigidity, or how rigid the straws are. And basically, rigidity is, think of like a basically a piece of spaghetti. Okay, how much you bend it would be the rigidity until it snaps. So let's say something is really rigid, you would hold it, and if you do a little bit of force, it would crack. Let's say something is not rigid, it would be flaccid. And that would be something like, let's say, um, a paper towel, where you hold it from both sides, you could bend it all directions. When with, let's say, dry spaghetti, I'm not talking about wet spaghetti here, but um, with dry spaghetti, if you bend it just a little bit, it'll snap. And that's one thing about rigidity, and that's one thing that you should take into account when you're building, because you're also trying to see how much force you're trying to put on top of those structures. And I think another topic I want to cover is that the supports on the bottom of your spaghetti, or your spaghetti tower, should be reinforced. What I mean by this is that, let's say you have just a regular square foundation. So you have a square of spaghetti made on the bottom, and these can't be taped to the table, by the way. I'll go over more of the rules and regulations in the second video, but these cannot be taped down to the table. So you have a square on the bottom. Now, the more spaghetti you have layered upwards and upwards and upwards would add to more force and more movement on the bottom. So one thing you can do is to add more spaghetti to the bottom. Let's say rather than do just one strand, you could do two, and see how much that affects the structural integrity of the tower. And if two doesn't work, then you could add another triangle, because think about it. If you have two lines going upwards and one line on the bottom, you could add another here to make a square, add a diagonal on both sides, and now you have a reinforced structure, where now either way that you push, it'll stay stable. And if you do that on all four sides, then you have a very, very good foundation. Um, I think also, once you get the tower down to the highest height, you could also think of different ways to move the structure. So let's say, you know, you're you've built it to the highest height, and now you let stand and see if it stands alone. If it is not able to stand by itself, then, well, you should try to build more structural devices. And I think my key thing to you is to add triangles everywhere within the structure, because triangles are, at least from the engineering term, one of the structural sound shapes, as I stated before, because once you push, it doesn't go down. And also, another factor that affects, or one thing, sorry, I'm going off track here. Um, so, when you do build it and it stands by itself, then you're good. But you could also, once you've built it to the highest height that you think is reasonable, because you have nothing to compare it to, you could now try to move it. So let's say you like push one side a little, and not like slam it across, but slightly push it and see if it's able to stand up. If it's not, then you could rebuild it and see if you can add structural sound beams from across. Because let's say when you're building, um, a bridge, have you seen those structures where they have like ropes tying the top of the building down to the, or on top of the building, no, the top of the bridge down to the floor, and these are like really tight ropes. You could try to implement something like that into your building, where rather than at the top, you could have a middle and it leans down on these two areas. So when, let's say, something starts moving it, let's say like an earthquake comes, and you want to see if your building is earthquake proof, you could try to see by adding if these two diagonal pieces, if it'll be able to stay aligned. And also, I think one last thing that I want to say about structural integrity before you go and start building is that it's really important to see how, or just to creatively think, because what I'm giving you right now is just tips on the building process and things that you can do to progress from, let's say, a basic building that's like this tall or like one spaghetti length tall compared to, let's say, a engineered building, which is what I want you to get out of this. So you could take this creative freedom anywhere. And, before you start building, before you go into the second phase of building, I want you to think of all the types of shapes that you can use. Well, that are able to be made from two sides. Or, yeah, so let's say you want to try to replicate a building. Okay, you could build it with four sides rather than two, or you could do it with three sides. Or let's say you want to before you like actually start, you could sketch out your drawing. You could sketch out like your plan, and that could be like your blueprint before you start. And I think I would recommend that to everyone because you could have, let's say, multiple blueprints ready to build, and you could see that, and you could like guess, oh, because this one has more structural support on the bottom, it'll be able to stay longer. And then you could, see which one of your three that you built, or two, or maybe just your best one if you don't have all the equipment, would reach the highest height. And if it doesn't work out, that's okay too. You could scrap everything that you had and go back to the drawing board and see, what can I do to make this better? Can I add a support here, a diagonal support here? Can I add more structural, you know, sound? Can I add a more structural sound foundation into the building? And before, while you're building, even if it doesn't work out, that's all right too. You could see on the fly, you can make innovation or renovations to your drawing. Let's say you see that it's leaning more to the right, and that wasn't accounted for. What you can do is that you could add more weight, because that's the problem of weight distribution. Because if it's not able to go straight up, it's going because there's more weight on one side or the other. And you want to even out this weight because you're trying to make it go straight up. So one thing you can do to you know stop it from leaning and make it more go vertically upward is to add another piece of spaghetti or another couple of pieces of spaghetti on the right side. And this will be able to shift that leaning straight upwards. And I think that will also help in reducing, the variability and the movement of your building. And I think, yeah, if you understood the topics that I said right now, I think you could go on the building process. So, yeah, good luck. I'll see you in part two.